All right, guys. So today we are looking at our notes for section 9.7. So what we're going to look at today is we're going to try to figure out when it is that we should use the law of sines versus the law of cosines. Up to now, we've always been told, hey, use the law of sines on this, use the law of cosines. But what about if they don't tell us? How are we going to know? Well, when we first learned the law of sines, we talked about the times when you can use the law of sines. And if we're trying to find sides, and we have angle, angle, side, or if we have angle, side, angle, that's when we're going to want to use the law of sines. Those two situations. If we're trying to find an angle, and we've got side, side, angle, then we can use the law of sines in this situation. Does anybody remember what happens, though, when we have side, side, angle sometimes? Right, so sometimes on this we have what's called the ambiguous case, where we have no solution, one solution, or two solutions. So A and B for ambiguous case. That just means we can have 0, 1, or 2 solutions. For the law of cosines, there are going to be a couple of times when we can use this. If we're trying to find a length of a side, we can use this when we have side, angle, side. If we're trying to find an angle and we've got side, 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 then this is going to work as well, law of cosines. Now, I don't suggest you memorize these cases because you can just kind of look at it and figure it out. It's not something that you really have to, know inside and out. So let's look at this first example and let's decide which one to use. If we can use the law of sines, then we should use it because it's the easiest one. So let's look at this. Could I do the sine of 39 over x, and then do I have enough information to set it up and use the law of sines? No, we don't. Because if I have this over this, I don't know an angle to put over that or an angle to put over that, and I can't find it. So this is a situation where we've got side, angle, side. What do we use on side, angle, side? We have to use law of cosines. So we're not going to actually do these problems. We're just going to state which one we'd use. Chris?
So it's side, side,
side. It's side, angle, side. So we have to use cosines. All right, looking at the next one, we see if we could use the law of sines. And we look at it and we could do the sine of this angle over this side. And then we would want to use the sine of this angle over this side. Well, could I find this angle pretty easily? Yeah. So could I use the law of sines? Yeah. And let's look at what we're given. We're given an angle, side, angle. Is that one of the times we should be able to use law of sines? Yeah. Angle, side, angle. Finding a side. All right, looking down here. Let's see if we can use the law of sines. I would do the sine of x over 8 equals the sine of 112 over 18. Would it work?
Yeah.
Yep. All right, you guys tell me on the last one. What would we use? Law of cosines. Yep. Yes?
So could you technically use cosine on a side digit? It just doesn't make any sense.
It wouldn't even work. Like if I got started and I tried to use law of cosines on this, I would quickly find out that I don't have enough information to even do it.
Not finding the measure.
No, we're trying to find the angle measure here, and you'd have to use law of sines. All right, let's go to the next page. We're going to do one problem here, and we're going to have to find everything, okay? This is when we're trying to solve a triangle. When we're solving a triangle, we have to know all the sides and all the angles. So they're telling us that we have to find the measure of angle S, the measure of angle T, and the measure of side ST. So we're going to start off by drawing a picture. We're going to fill it in. Angle R is 55 degrees. Side RS is 17. And side RT is 9. So I want to decide what law I'm going to have to use and what I can find, first of all. Well, I don't have to find that first. I can find anything I want to find. I have to find everything, so I'm going to see what I could find. What could I find pretty easily, guys? Yeah, I could find this side right here, can't I? So I'm going to call this X. And because I have side angle side here, I can go ahead and I can use that law of cosines. So it's going to be that X squared is going to equal. Do you guys know how to set it up? 17
squared minus 2 times 9 times 17 times cosine of 55.
Awesome. Okay, so we're going to use that law of cosines, and we're just going to plug this all in at once. So what are we going to end up doing to solve for X? We're going to have to take the what? Right, so we're going to have to take that square root. And that's going to tell us what X is. All right, did everyone get 13.9? Okay, so that is the length of side ST, 13.9. Now, here's the thing with that. I cannot use this rounded version when I go to figure out the rest of this problem. I can't use this rounded version. It's actually going to end up not even working. So if I go to set this up, I would do the sine of 55 over, and if I use this 13.9 equals, and then I can use either one of these. What do you guys want to find, S or T? We'll do, I don't know, let's do T. We'll do sine T over 17.
So we're not doing that?
What?
We're not supposed to do that?
I'm going to show you why I have to use the full version. I just don't write this down yet. We're going to cross multiply, and I would get 13.9 sine T equals 17 sine 55, right? So to type this in, I would do 17 sine 55 divided by 13.9. Now, what's wrong with this? It's over 1, isn't it? When I try to find the angle now, when I do second sine of that answer, it's going to give me an error message. The reason that happened is because I rounded here. You cannot round there. So if I have to use the full version, watch what I can do. I'm going to go back up here. Okay, I'm going to go back up here, and I'm going to store that. What is the name of this side right here? I called it X, but I could also call it, it's across from angle R, so I could call it R. So what I'm going to do is I'm going to push enter on this, and I'm going to store it in for alpha, and I can use any of these letters I want, and I'm going to store it into R, and I'm going to push enter. That is now stored into R. So now when I do this problem, it's going to be R, and I'm going to put an asterisk because I know what R is. Sine T equals 17 sine 55. So how would I get T by itself? What do I need to divide by? Divide by that R star, which I know. Okay, so now I'm going to type that in. So I'm going to do 17 sine of 55 divided by, and I have to get that R, so I'm going to do alpha R, and I get this answer. Do you see how that rounding really changed that a lot? I got an error message. I couldn't even do the problem. But now, what am I going to push to find out what angle T is? What do I do, guys? This is sine t equals this answer, this 0.9985. So what do I push to find the angle? Second sine. So I'm going to do second sine of this. And I'm going to push enter. So what is that angle then to the nearest degree for angle t? 86.9. We'll round to the nearest tenth. I think I said degree, but to the nearest tenth. Yeah.
How do you do this with the TI 83?
There still should be a store button on there, but you might have to actually redo this part of the problem to get the answer because you can't scroll up. Now, the other thing you can do on that older calculator is you can keep pushing second enter, second enter, second enter, and you can get all the way back up to things you did a long time ago just by pushing second enter. See how it's going back to things I did earlier in the day. Okay, so you can also try that. Now, to find angle S, so I know angle T was 86.9, and I need to find angle S. So now I'm going to do 180 minus 55 and minus this angle here that I just found. Don't round until the end. And so what's angle S going to be? 38.1. I did 180 minus these two angles to get the other angle. All right, guys. So I wanted to do that problem to show you that you really have to be careful with the rounding. If you round too early, then you're not going to be able to solve the triangle. And that's why storing that exact answer is a helpful thing. All right, let's go over here now. We're going to talk about how to find the area of a triangle. So to find the area of a triangle, we should know this is going to be A equals, for this triangle, how do we find the area? 1/2 the base times the height. 1/2 base times height. Our goal here is to come up with another formula for the area of the triangle. Okay? So here's what we're going to do. We're going to look at this part of the right triangle. If I have a right triangle, I can say that the sine of angle C is going to be opposite over hypotenuse. So in this case, what is the opposite of angle C for this right angle? H over A. Good. We're going to find another name for the height using this. So if sine C equals H over A, then what's the height going to be? How can I get rid of divided by A? So multiply by A. So H is going to be A sine C. And now we're going to substitute that into our area formula. So we're going to have our area formula then is going to be 1/2 base, and then what's another name for the height? A sine C. So that's a formula that we can use to find the area of a triangle. 1/2 AB sine C. What do you think another formula would be? 1/2 AC sine what?
A.
No, B, right. Or we could do A equals 1/2 BC sine what? A. Good. All those formulas will work. Number 3 is one we're going to do together. When we look at this triangle, we've got two sides and we've got the angle in between it. This formula will always work when we have side angle side. If we have side angle side, this formula is going to work. So when we're looking at this triangle though, what are the sides that are going to give us side angle side? Am I going to use this one? So I'm going to have to use these two sides. I'm going to use these two sides, and then what angle? 25 degrees. So our area formula then is going to go 1/2, and I just have to use these two sides and then times the sine of this angle. So now try typing that into your calculator. Are you guys able to get this, 119.2? Okay, so then that means that our area is going to be 119.2 square inches. Remember, we use square inches when we're talking about area. All right, guys, I want you now to try to find number 5's area. Think it through. Remember, you must have side angle side in order to use this formula. All right, raise your hand when you think you know it. Okay, Maya, what'd you get?
97.5 meters squared.
Olivia, did you get the same thing? Great. 97.5 square meters is correct. That's the setup. Okay? Yeah, Maya.
On number 3, is the equals, and number 5 is the
This should have been approximately.
Actual.
Anytime we round, we should be putting these squiggles to mean approximately. All right, we're going to learn one more formula over here on the back. So if I'm trying to do this problem right here, do I have side angle side to be able to do it?
No.
So I would actually have to use either the law of cosine or the law of sines, and I would have to find either a missing angle or a missing side to be able to do that problem, right? That's going to take a lot more work. We're not actually going to do one of those, but that's what would have to be done.
So basically you find one that's near.
Right. So if I could find this side, that would give me side angle side, and it would allow me to solve the triangle. However, I don't think I could even find that side yet because I can't use the law of sines on it. I think I would actually have to find this angle with the law of sines. And then once I knew that angle, I could find that angle, and then I'd have side angle side. See how I'd have to do that? And sometimes you might start off finding the wrong thing at first, but that's no big deal. You just keep working through it until you get it so it's something you can use that formula on. But the new formula I want to show you is when we have side, side, side. You don't actually have to use law of sines or cosines if you have side, 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 because there was this mathematician named Heron who came up with this formula for area. This is Heron's formula for area. It only works, though, if we have side, side, side. The first thing you have to do on this formula is find the semi-perimeter. What do you think the semi-perimeter means? Right. We're going to call that S, and its semi, of course, is half, so it's half the perimeter. Once we find that semi-perimeter of S, here's the formula for area. It's going to be the square root of s times s minus a times s minus b times s minus c. The reason I like this formula better than using the law of cosines is because the law of cosines, finding angles, is pretty difficult to do. And it's pretty easy to find the semi-perimeter and then use this formula. Okay, so does everybody understand the formula? You find the semi-perimeter, half the perimeter, and then it's just this, the square root of the s minus a, s minus b, s minus c. Let me show you on a problem. Where's the first problem where we are given all three sides? Yeah, so number 9, we're given all three sides. So we're going to find that semi-perimeter. So we're going to add these all up. What's 21, 15, and 23? 59, right? So the semi-perimeter is going to be half of 59, which is 29.5. So now my formula for area is going to be, I plug in 29.5 for S, and then I'm going to have to do 29.5 minus each of these sides. So 29.5 minus 21 is what, 8.5? 29.5 minus this 23 would be 6.5. 29.5 minus 15 is 14.5. Is there a question? So once I get all of these in here, now I just need to use my calculator. I'm going to show you something else you can do. You guys do it that way. I want to show you something else though. So I'm going to store 29.5 in for S. This is pretty cool. And then I'm going to show you, I'm going to do look what I did. I put it in, I stored S in. See how I stored in the S value of 29.5? And then I literally used it in the formula. I just did S times S minus A, S minus B, S minus C. And this is the answer everybody should have gotten. Did everybody get 153.7? Okay, very good. So our area then is going to be approximately, I have to round it to the nearest tenth, so it's approximately 153.7 millimeters squared. All right, guys, you try one on your own, number 10. Anybody got it? What'd you get, Nolan?
138.9.
Anyone else get 138.9? Great. Guys, I want to show you the coolest thing now. Okay, so I just found the semi-perimeter and I stopped. Okay, here's what I'm going to do. I'm going to store this semi-perimeter in for S now. I'm storing it in for S. Instead of me having to type in the square root of S, S minus, etc., watch what I'm going to do. Remember how Vlad was asking me, how can I get back to something that he did earlier? Watch, I'm going to do second enter, second enter, second enter, second enter. Okay, so I get back to here. And now this is what I'm going to use, but I'm just going to change these. So this is going to be S minus 17. This is going to be minus 22. And this is going to be minus 16.5. Boom. Oh, no. Oh, that's right. I thought it was the wrong answer. I was like, what? That's the right answer, 138.9. Okay, but isn't that pretty cool? Like we can actually put things into our calculator almost as formulas and do it that way. As long as I change that S value. Get the S out?
Yeah.
You don't need to get it out. It's going to always stay that until you change it. So I can make S anything. I just keep changing S to whatever I want it to be.
How do I get on the calculator?
Okay, so let's say I want my semi-perimeter to be 36. I would type in 36, and then I go to store, and then I put it in for alpha S. Enter. Oops. And now my semi-perimeter, my S value is always going to be 36. And then when I want to use it, let me scroll out a little bit here. If I now want to use S, I just type it in, the square root of S, alpha S. Well, what should the answer be based on what I just put in? 6, and it is. Okay? It's just kind of an interesting way to do the problems. Just makes them, a little different. So feel free to store things as you go. All right. Are there any other questions over anything we did?